So hello guys, now we have already seen how to solve an exact differential. Now what if we have found an equation, our differential equation is non-exact. This means the differential of m with respect to y is not equal n with respect to x. Now if we get a differential of m with respect to y, it's not equal the derivative of n with respect to x, we are saying this is non-exact. Okay, so how will we solve for this non-exactness? We are saying first to solve for this non-exactness, we'll say find an integrating factor. So our first step is to find our integrating factor. So check my videos on integrating factors, so I introduced that. So find the integrating factor, then multiply through. Okay, then multiply it to all the terms in the differential equation to make it exact. Okay, to make it exact. So for this example, we are saying our first step is to make it exact. So before that, let's check for exactness. So our first step is let's check for exactness. So let's say check for exactness. So how will we check for exactness? We are saying if we take m with respect to y equal n with respect to x, we'll say that is exact. So for our case, we are saying this is our m, and then this is our x, this is our n. Now we are saying let's check that. We are saying m of x y equal x minus y squared, and again we are saying n of x y equal 2xy. Now so let's check for exactness. We are saying first check for exactness. We are saying the derivative of m with respect to y. So we are saying where there is a y, let's treat every term, the x term, as a constant. So if we differentiate this x term, we should get a 0. If we differentiate this, we should get a negative 2y. And again, if we get this m, this should be n, sorry. So if I take the derivative of n, with respect to x, so where there's a y's, I'll treat them as a constants. Okay, now saying I'll take 2x as my constant. Okay, so I'll take 2y as my constant, then differentiate x, I should get 1, so I should get 2y. As you can see, negative 2y, it's not equal to y, so it means this differential equation is non-exact. So how do we make it exact? So our first step is to find an integrating factor, Okay, so this we are encountered by this problem. We are saying find the integrating factor. So integrating factor is simply a function of x, or y, or both x, y. Now how can we find this integrating factor? So we have two cases. So I'm saying case 1. I'm having case 1. So I'm saying if m of y minus n of x divided by n itself is a function, okay, is a function of x alone, So I'm saying if m of y minus n of x divided by n is a function of x alone, then I'll get my integrating factor, which is mu of x. I'll get my integrating factor as e raised to the integral of because we are saying, so all these things, we are saying include this. So I'm saying include these label it as epsilon of x. Okay, so I'm saying the integral of epsilon x then dx. Okay, now I'm saying if m of y minus n of x, so this is just the derivative of m with respect to y, and again if I subtract that with the derivative of n with respect to x, then divide that by the whole function. So this is the function, so I should get my and this must be a function of x alone. I should get my integrating factor as e exponential raised to the integral of epsilon x dx. So let's perform this. Okay, so let me introduce case 2. So we usually have two cases, so I'm saying let's introduce case 2, for example. So I'm saying let's introduce case 2. Case 2 is where I'm saying if m of y minus n of x divided by negative of m, okay, divided by negative of m is a function of y alone. Okay, is a function of y alone, then I'll get my integrating factor mu of x as e raised to the integral of psi of x should be psi of y. Okay, so it should be psi of y. Sorry for this. Should be psi of y dy. Okay, now so for us to solve for non-exact differential, we are saying we have two cases. So let's our first case, let's perform case 1. Okay, so let's get our m of y minus n of x. So we are saying what's my m y, what's my n of x, and what's my n alone. Okay, so I'm saying my my, so I'm saying my my from this point we are seeing our my is -2, and then this is 2y. Okay, so our my it's -2y, and then this is 2y. Our function alone, our n of xy, it's 2xy. Now from this point, let's operate these. We are saying -2y minus 2y divided by 2xy. Okay, so I'm checking if it's a function of x alone, we should get our integrating factor as mu of x equal the exponential to the integral of epsilon x. Now we are saying, so let's subtract this. We are saying, so this is -4y divided by 2xy. So this y cancels y. I'm getting so this is just -2. I'm getting -2y. I'm getting -2 upon x. Okay, so as you can see, this y cancels this, and then this cancels this. I'm getting that. Now as you can see, this function, it's dependent only. So as you can see, it's dependent only on x. So it means I'll use just the first case. Okay, so if you could have gotten maybe this function is not dependent on x alone, you should perform case 2. Now so we have case 1, which is true for this statement. Now we should get our integrating factor equal e raised to the integral of now this. Okay, now this expression which we said this is epsilon of x. Now so equal epsilon of x dx. So let's perform this integral. We're saying the integral of -2 upon x dx. As you can see, taking 2 outside my integral, get the integral of 1 over x dx. So this simplifies to -2 ln of absolute value of x added to a constant. But keep in mind, we are not including the constant of integration at this point. Now I'll get my integrating factor as e raised to now the integral of this. So this is just simply ln, okay, of x. Now properties of logarithm allows me to take this -2 to to be the power of this x. So it's just raised to negative 2. Okay, now so e to the ln is simply 1, so this goes down to 1 over x squared plus a constant of integration. Now once we have already found our integrating factor, we are saying take the differential equation that we were given. So our differential equation was x minus y squared dx plus 2xy dy equals 0. Now, having this integrating factor, we are saying multiply it through to this. So I'll multiply these to with 1 over x squared, multiply this term with 1 over x squared, and multiply again this term with 1 over x squared. So what will we get? So we are getting x minus y squared divided by x squared dx plus 2xy divided by x squared dy should equal 0. Now, so let's separate these. We are saying from this point, we are saying it's x divided by x squared minus y squared divided by x squared dx plus, from this point I'll be remaining with 2y upon x dy should equal 0. Now if you continue this, we are saying this is just 1 over x minus y squared upon x squared dx plus 2y over x dy should equal 0. Now this differential equation has already become exact, so has become exact. Okay, so from this point now, let's check for exactness. I can write this as x raised to negative 1 minus y raised to multiply that by x raised to negative 2 dx. Okay, added that to 2yx to negative 1 dy should equal 0. Now this has become already we have changed it from non-exact to exact. Now we can check for exactness. From this point we are saying so this is our m. Now we have gotten this is our new m and this is our new n. So I'm saying delta m with respect to delta y. I'm saying where there's our x are treated as a constant, so this is a constant, then from this point I'm saying integrating this I should get negative 2y. Okay, this should be a constant, so just remain the way it is, so it's just similar as divided by 2. Now let's get delta n upon delta x. We're saying where there is a y, it's a constant, so from this point, so the y is constant, so it's 2y divided by r. To this point, if I differentiate this, I'll take negative 1 multiply in front. The negative 1 I'll multiply in front, then minus 1 to this power. So I'll multiply that by negative 1. Then if I subtract another 1 from this point, so if I subtract another 1, I should get negative 2. Okay, so I should multiply that again by x raised to negative 2. Okay, so this is simply negative 2y upon x squared. So as you can see, negative 2y upon x squared is the same as negative 2y upon x squared. Now, so this statement is true, so it means the differential equation has already become exact. So how will we solve for this differential equation? Now we are saying get the integral of delta m with respect to we are saying respective to delta x, and then get the integral of delta n with respect to y. Okay, so let's perform this. So I'm saying the integral of delta m with respect, so I'll say it's the integral of what's our new m. This is our new m, keep in mind. So our new m is x to negative 1 minus y squared multiplied. So it's minus y squared multiplied by x to the negative 2 dx. Okay, x to the negative 2 dx. Okay, so let's perform this. Having this, we are saying, performing this expression, we are saying we'll get, if we differentiate this term with respect, if we integrate this term with respect to x alone, we should get our answer as, so let's integrate this. So if we integrate this, is just ln. Okay, so this is just ln of x. Okay, then subtract that to, if we integrate this with respect to x, I'm putting my y as constant, so this is y squared multiplied by, if I integrate this, I should add 1 to this power. Okay, then subtract, divide by the new power. So I'm saying I'll multiply that with x raised to negative 1 divided by negative 1. Okay, now then from that point I'll add a constant of integration, but we won't add this point. So I'm saying this is ln of x minus, so this minus comes up and it becomes y squared upon x. Okay, now so this is our integral. Now let's continue. Let's find the integral of delta n. Sorry, so let's find the integral of n with respect to x. We are saying, for us to get the integral of n with respect to x, so delta n with respect to y. Okay, so I'm saying it's the integral of so what's our new n? Our new n is simply 2y upon x. Okay, so our new n is simply 2y x to the first. Now this is dy. So integrating this, we are saying keep the x term a constant. Okay, so keep the x term a constant. Now let's integrate this. We'll get multiply that by 2y raised to the second divided by 2. Now I'll get this as x raised to negative 1 y squared upon 2. So these two cancels each other. Now we are saying so this is our answer. Okay, now I can simplify this as y squared upon x. Now, so for us to get our potential function, we are saying our potential function, for us to get our potential function, so I'm saying potential function, so our potential function, which is our original function, I should write f of x y equal a constant term. Now I'm saying I'll write the terms in our answers that we have gotten from the two integrals. We are saying this is our first answer, so this is our second answer. So I'll write every term without repeating itself. Now I'll write our potential function f of x y similar as ln of x, then I'll add that to y squared upon x. So as you can see, y squared upon x has repeated itself, so we won't write it again to this part. So simply, so this is our answer, then I'll equate it to a constant term. Okay, so please check for the another example which continues to extrapolate more on the case 2. So for this case, we have done with case 1. So please like, share and subscribe to my channel. Have an amazing day.